So can I, if I fold that into you,
Yep.
you get that strap on it, adjustable that you had?
Mm-hmm.
You keep the same strap as
The hook.
yeah.
You can tell it's warmer over here in my hand.
Yeah, definitely warmer.
Yeah.
Okay. Question is, we try to make it one more fold or not?
End of the pizza towards the crust.
So let me release this last adjustable. Okay. So this is to come into you, right?
Mm-hmm.
What's that thing?
Okay, I'm going to hold it. Get the adjustment. Pushing it. Anything to hook it to?
Hook it to you. Hook.
Oh, I see it. Yeah, nice. Okay.
Now it should go back to the bag. I don't know if there's any point in trying to fold it one more time or not.
Maybe once it's right next to the bag.
Yeah. So that one is cinched up.
Yeah. All right, I'm going to go circumferentially around to the other side so I can be on the other side of the bag.
Okay.
And that Node 3 pressurized mating adapter cover removed, the astronauts are now working to stow it into the ORU bag.
"20 seconds to handover."
In this view, you've got your flight control team for the day. Allison Bollinger is the lead flight director, down in the blue shirt and black jacket. To her right, Canadian Space Agency astronaut Joshua Kutrick serving as the ground IV and communicating the tasks from the ground to the International Space Station.
We just want to check that the bag is closed up, and then we're going to pause for club and half inspections from each.
Okay, the bag is closed up. You got the backstop end is cinched too, right? So.
Yep.
Cap is dry, so that's still good. And gloves-wise, my right glove still looks to be in good condition. Left glove, a little bit more RTD on the index finger. But other than that, no change.
Copy, Bob.
And EV2 dry hat. Gloves look really good, actually. I don't see any change at all.
Copy, Chris. So at this point, Chris, we're going to proceed with a cable tieback. This has you going in towards the center disc cover, and you're looking for the connection on the antenna side. It's 1004 plugged into, on the CBCS side, 1449. That's what we want to find in DMate.
On the antenna side, 100. 1004, right here.
Affirmative. It should be plugged into 1449, and we're go for DMate.
Chris Cassidy looking to disconnect and tie back the external wireless communications cable in this area.
Chris, for your positioning, once that DMate is complete, 1004 will be getting tied back on the handrail that's sort of adjacent to your left boot. It'll be rail 0661.
0661.
Yeah, just on your left hand now. We show there being wire ties already there, a short one and a long one, and we'd like you to tie 1004 off to the white taped long wire tie.
The white taped long wire tie. Copy that.
And Bob, see you already over the center disc cover. We're going to be looking to pre-install one long wire tie on the Zenith CDC handhold.
Okay, first I'll put the cap on if that's okay.
Sounds good. It can mate to any cap.
Okay, there's only one available cap here.
Roger.
And then you want me to pre-install a wire tie to the Zenith.
Good words, Bob. Zenith CDC handhold, and the long side of that wire tie we want to bias towards the CBCS opening.
Okay.
And Bob Behnken just mated one of the cables Cassidy disconnected to an empty cap. He will now tie it back with a wire tie to secure it.
And Chris, as you go about that tieback of 1004, looking to make sure that it stays clear of the CBM ring.
Roger. Ball's always right side up.
I don't know about that.
I don't know how this handrail got underneath the cable. Is this an on-orbit installed handrail? No? No, it's not.
And Chris, we don't think it is negative. Chris, further words on that tieback that we do. Shield 3 is going to be coming right on top of it, so as long as it's flat up against structure, we don't anticipate problems.
Okay.
This view from Chris Cassidy's helmet camera as he wire ties that cable back.
Back is complete.
Copy, Chris. Just finishing up some tiebacks with Bob. And Chris, if you wanted, you could position up by the crew lock bag. Next, you'll be retrieving 2 tether extenders for the shield tiebacks.
Copy.
In this view here, you have a great view, actually, of those shields that are about to be tied back by the astronauts.
Your go to remove it, Chris.
You can see the numbers 2, 3, and 4. Cassidy and Behnken will work simultaneously on shields 2 and 4 to tie those back and into place. And then Cassidy will move on to tie back shield 3 with Behnken's help. This is all in preparation for the arrival of the NanoRacks airlock later this year.
And Bob, we see you starting to wrap the wire tie around those 3 legs. Just a reminder to open up the flap before you do end up pulling it all the way back.
Copy.
Looks good, Bob. And so at this point, looking to capture all 3 of those 1449 cable legs into your one long wire tie and gently pull it back to the edge of the CBCS opening, back strongly enough so that it doesn't get in the way and weakly enough so that we don't deform, kind of right in the middle.
Copy.
Oh, it's Behnken. Trivial.
And Chris, yeah, we concur. Chris, since you are working with pit pins already, well, a couple cautions there. Basically, the shields are good for tethers and translation when they're installed with the quarter turns, but once we start pulling them back, we want to limit any inputs onto the shields to 45 pounds force.
Okay.
Bob, checks for the end of your task, we'll be looking to confirm 3 half twists in the wire tie and then a WVS survey of the CVCS opening.
Copy. got that 3 half twists on the long wire tie. And it appears to be pulled over to the side pretty well and kind of a little bit integrated with the caps over here. Because there's a bunch of big bundle. See that configuration.
Copy, Bob. Copy on the 3 half twists and copy on the WVS. We see it. It looks to be in a good config. And Bob, I just received final word. We're happy with the CBCS. So next for you would be up to the crew lock bag to retrieve 2 tether extenders in preparation for the shield tiebacks.
Okay.
And the crew will be moving on to tying back those shields that you can see numbered there, 2, 3, and 4. You also may have noticed it got darker outside the International Space Station. The station is flying 261 statute miles over the North Pacific Ocean in an orbital nighttime.
To the crew lock bag.
Copy.
As our astronauts continue this work preparing for the future NanoRacks airlock, we are still accepting Ask NASA questions. So if you're watching live, send us a tweet on Twitter with the hashtag AskNASA. This one from Haley asks, how does being underwater in the spacesuit at the NBL, or Neutral Buoyancy Laboratory, mimic the same concept as they do their actual spacewalks? You're onto something, because being underwater is the closest we can get on Earth to experiencing weightlessness or microgravity. Being in the spacesuits underwater also allows the astronauts to understand how it feels to maneuver in the suit in that type of environment.
First one, yeah.
Okay.
A bit of effort.
The Neutral Buoyancy Laboratory is a 6.2 million gallon pool here at Johnson Space Center in Houston, Texas.
You got a red on it.
All right, I am ready. Actually, I think I'm supposed to be ready to the
You want to be ready to this out
other
there?
end. Yeah, let me. So. Ready?
Got it.
And Chris and Bob, just a possible efficiency for you. We're okay with going out of order. So the plan was for us to go shield by shield, but if it makes more sense for you guys to work together circumferentially around and just do all the pip pins, then the tiebacks, we're good with that as well. Just whatever's going to be easiest.
Probably some kind of hybrid. All right, I'm working on Channel 3, and one pit pin is done, kind of the nadir side, and that tether loop is also installed, and also on that nadir loop is the grounding strap looped through strap.
Copy, Chris.
Go down to the other one on the opposite side.
Okay. On 4, I guess it is.
Yeah, 4. I don't think there's not enough room for both of us right there.
Yeah, I don't think so.
I see what you mean. The strap is wider than the slot.
What I ended up having to do was take my pin and poke.
I'll poke it.
Yeah, once you get it initially through that first hole and the first part of the strap, and then it bunches all up. Okay. But Josh, I got both pit pins, both straps, and the grounding strap. I'm ready for quarter turn fastening.
Copy both pit pins and the grounding strap on shield 3, Chris, and we concur.
Okay, I've got one of the pit pins on 4.
Copy 1 on 4.
And on to the second one.
Cassidy and Behnken are now working simultaneously on these axial shields, number 2 and 4.
Kind of bunched up, made a bunch up of the loop, and then once I got that opened, I kind of partially inserted the pin, and I was able to loop it around.
Yeah.
Cassidy actually removing number 3 first, relaying some best practices to Bob Behnken as he continues to work to release number 4.
The chick is not getting any of it into the hole on the other side.
Right, exactly. That's what I was struggling with. Josh, do you want to do the tidying up, cinching up now on 3, or should I? Do you guys prefer?
Chris, we're taking a look right now. It looks good to us in the camera, as long as you're content that it is going to stay there. It does look good to us, and we're happy for you to move on.
No, I'm not happy with it. I was just getting ready to cinch. I was wondering if you wanted to wait on cinching 3 or just kind of okay.
Gotcha. No, we're go for you to cinch shield 3.
And Josh, remind me where the handrail that's good for the larks is.
And Bob, you're broken. Say it again.
Just remind me where the generate the lark snot from.
Copy. So on the kind of the top surface of the shield that you're looking at, there's two handholds, two shield handholds, and we're going to run one tether extender through each one. Lark's not there. Affirmative. I see it in your right hand.
So it needs to just go through larks. It's going to rerun through both of them, but just lark's snotted through one, right?
Both will end up at the end with the lark's knot through each handhold.
Yeah.
Each handhold. Okay, so we'll use both tracks, right? Okay.
Affirmative. And that looks good on the right, Bob.
As you can see, that third axial shield has been tied back and down out of the way. Cassidy is now working on axial shield number 2, while Behnken continues working on number 4.
And Bob, those two lark's knots look good to us. For Bob, we just want to cinch the lark's knots up nice and tight so that they don't have any compliance.
Copy. That captures the pit pin, shield 4.
Copy, Bob.
Okay, both pit pins on shield 2.
Chris, we copy both on 2.
As you can see, Bob Behnken has removed that shield number 4 and is working to tie it back.
Side, you need tie back, eh?
Yeah, no problem.
And a final caution as we work towards having all the shields pulled back is to avoid the CVM sealing surface.
Okay. How long till daylight, Josh?
Looks like about 6 minutes, Bob.
Okay. Think about the inspection and doing that in the day.
And Bob, that's exactly right. From here, once everything's tied back, you'll be providing some video, doing the CBM sealing inspection, and then we'll be packing up to go back.
I think shield 4 is complete.
Copy complete on 4.
Imagine that bag with 4 more adjustables in it.
Yeah.
It's going to be a lot to keep track of. They all look the same, these. So the next thing I can do, Josh, is just start getting ready for the inspection. It's probably a single person on top of the shield task.
Bob, that's affirmative. What we have here is we'll anticipate Chris finishing off shield 2, and if you can get the GoPro ready and turned on, we'll film some footage of the CVM sealing surface and give it a good inspection, looking for metal and anything with vertical relief.
Okay.
Bob Behnken has completed attaching the 4th shield. Chris Cassidy will now continue to work removing axial shield number 2. Once he has tied that back into position, the main work at this work site, node 3 or the Tranquility module, will be completed. The astronauts will clean up before heading to their next tasks.
And for Chris, it's hard to see from here how far that shield's going to go when you pull it back, but we just want to make sure it doesn't end up covering your green hook.
Okay. Good reminder, thank you.
And Bob, when you have a minute, we're hoping to look at the shield 4 for some comments.
Go ahead with 4.
We just saw it moving a little bit. We wanted to make sure that the tether extenders don't have a chance of sliding up onto the dog rail portion of the handrails. and putting more compliance into that shield. If you think there's a risk of that, we'd suggest moving the tethers further radially outbound.
Okay, I'll try to cinch it up a little bit more, trying to be careful not to pull too hard on those handrails.
Yeah, we concur. Another idea might go to go to a separate handrail, so one more radial outboard, so that the tether extender kind of opens up away from the shield at a wider angle.
Let's tag up panel 2. Pit pins installed, 2 lark nuts installed with the tethers. The grounding strap is through one of the tethers. Quarter turn fastener is released, and I am moving my green hook before I put this down.
We copy all, Chris. It's a good config. We're ready to tie it back. And we see you working, Bob, just to confirm that we don't put the safety tether over, the lark tether over a safety tether.
Okay. Is that how you want them? It's looser here.
And Bob, we think Shield 4 is in a good config. It's hard for us to see. We just want to make sure that there's no chance of it, the tether riding up and over onto the dog rail and then the shield coming up towards the stovepipe. But right now, we have the separation.
Yeah, it can't come up over the dog rail because it's hooked to the standoff, but I can't make it any snugger because of it's not long enough.
Reasons.
Physics.
Okay, if it can't come up over, that's the part we're not able to see from here, then we concur. I think it's good.
It can do is flop a little bit, but it is what it is without a cinching mechanism.
Yeah, the flopping is fine so long as it doesn't move inboard, but I think it looks like it's in place good.
Okay.
Yeah, I have one too that's kind of between.
Yeah, we see it.
A good look at all 3 of those axial shields removed from the Node 3 end cone and tied back out of the way, preparing that space for the future installation of the NanoRacks airlock.
Okay.
You have a GoPro too, Chris?
Do, yeah.
You want to just put it in half and go around here?
Yeah.
I've only noticed one place on about this half that's got a little bit of something on it, it's got a little bit of relief to it near the bolts.
Copy, Bob. And Bob, can you take a stab at what that could possibly be? We're interested in whether or not it appears to be metal or if it could be liquid or grease or something like that.
I would hesitate to speculate what it could be without, pushing on it a little bit. It looks like a speck, got a little bit of a shine to it, but a lubricant could do the same thing.
Copy.
Coming up on 4 hours into today's spacewalk, you can see the astronauts are at the Node 3 work site. That's the Tranquility module. They have just tied back 3 axial shields, preparing this space for the future installation of the NanoRacks airlock.
Nothing vertical on your side, and Bob, we're still assessing in video.
The crew is now taking footage of the work site to be relayed to the ground for future inspection.
This right here, or this bolt on this side, Chris.
They will then begin cleanup of the site before moving on to their next tasks, which involves cable routing.
And guys, we definitely have sufficient time here to try removing it with wipes or the scraper, but looking for your input on whether or not you think that's worth a try or something that could be effective.
Okay, I think we could try the scraper, and we can just go right away from the bolt hole. It's a pretty small fleck. I'm guessing that it's a dry lube, based on there are some other small flecks near the bolt that appear to be, some dry lube. So this one is a little bit bigger than that. It's bigger than a pinhead, so but I think the thing to do is just the scraper.
Copy, Bob. And so, Bob, it sounds like we'll give that a try if you want to retrieve the scraper, the cats. I'll read some cautionary notes to you. Of course, don't touch the FOD, and be careful not to push or scrape debris into or towards the CBM bolts.
During their inspection of this Node 3 area, the astronauts discovered some FOD, or foreign orbital debris. They will attempt to use a tape scraper to remove that.
Get into this side of the crew out back.
Yeah.
A short satellite handover here, and you are looking at a view of the International Space Station Flight Control Room in Houston, Texas. The International Space Station is currently flying 268 statute miles over South Pacific Ocean.
Okay. It's going to be one of those things that comes off with a little bit of a little push.
Yeah.
sunny over here.
She's not here.
She is.
Oh, John, camera while you do it. And I need the light on a certain angle to find it.
Yeah.
Chris and Bob, there's 4 hours. 4 hours. We have a 7-hour PET available, limited by Bob's Medox. We're on timeline. If we pause here for the FOD, we'll probably be slightly below, but lots of time remaining. And as we see you working there, just a reminder to scrape away from the CBM bolts. We want to avoid contact with any RTLs or latches, and do not use the wipe to clean the CBM sealing surface.
It's removed. It was definitely shiny, like it was metallic. Just a little bit of a bump, and it floated away.
We copy. And Bob, with you out there with the tools, looking for a final inspection and confirmatory that the ring now looks good.
Your half of the ring looked good, right, Chris?
A-firm, yep.
My half of the ring looks good as well. I don't see anything protruding above the plane of the CBM on internal or external.
Copy, Bob.
Okay, so is the next to recover the large ORU bag and bring it to the airlock?
That's affirmative, Bob. All of that. You need the scoop first out of the crew lock bag, and then you're taking the ORU back to the airlock. Chris, next up for you will be an inventory of the crew lock bag.
Roger. I'll just take the scoop, Bob, and I'll take both these bags back to the airlock and pick up.
Sure. Sounds good.
We copy.
And that foreign object debris easily removed by the scraper used by Bob Behnken.
Sorry. A little crazy.
That wraps up the tasks here at the Node 3 work site.
I have the scoop.
You got the scoop.
Bob will ask for a glove and half just before you pick your green hookup.
Copy.
Ready, Josh? Crew lock bag.
We're ready, Chris.
There's 4 integral rets. 3 of them are blank. One of them has a 2 extender chain. There's a small ret that's empty. Just to have the scoop, I believe. There's a ret to an adjustable with a wipe and scraper. And then a ret to an adjustable with 2 wire ties. It's complete on the inside.
And Chris, the inside of the bag looks good. Just let me know what's on the outside.
Let me do a little removing my own threat from that paper.
I tried to take some pictures of the VM surface as well as of inventorying.
Oh, we appreciate it.
And on the outside of the bag is just a large, small adjustable.
That's a good inventory, Chris, on the Kerlock bag. So from here, Chris packing everything up to take both bags back, and Bob basically just heading straight out to your next work site. I can take a glove and a half from each of you when ready.
Copy. My hat was dry. And my right glove still clean. Left glove, same flap on the index finger. That's it.
Copy,
I'll
Bob.
recover my green hook.
Copy.
And for EV2, dry hat. Those are no change at all. They look really good.
Copy, Chris.
We are now 4 hours and 10 minutes into today's spacewalk, which started when our astronauts Chris Cassidy and Bob Behnken switched their suits to internal power at 6:12 a.m. Central Time this morning, 7:12 a.m. Eastern. So far, the astronauts have accomplished a number of tasks, the first being the installation of RITs. RITS is that robotics tool storage, which is a protective storage unit outside the International Space Station. There was also some cable routing associated with that installation. The astronauts then moved on to remove the H fixtures. One was the 1A H fixture. These were used for ground processing the solar arrays prior to their launch, but needed to be removed prior to future power system upgrades.
One on my BRT.
We copy.
On the first attempt to remove those H fixtures on July 1st, the astronauts ran into a little bit of trouble, but they were able to remove them cleanly and quickly today. As Cassidy worked to remove the 1AH fixture, Bob Behnken completed some cleanup at the Integrated Electronics Assembly, where the most recent 3 spacewalks have occurred. He then moved over to remove the 3BH fixture, another successful removal. Both astronauts headed back to the airlock for a safety tether reset before moving to Node 3, or Tranquility. Once they reached Tranquility, they began to prepare the area for a NanoRacks airlock to be installed once it arrives later this year. The next work for the astronauts will be more cable routing. Chris Cassidy will work to route the CP3 Ethernet cable, while Bob Behnken works to route the CP13 Ethernet cable.
Across node 1.
Copy, Bob.
After completing his cable routing, Bob Behnken will then work to remove a lens filter on one of the cameras outside of the International Space Station.
You'll notice I did put some fair leads in on your tether. Start heading back. Okay.
We are still taking your Ask NASA questions today, so don't be shy. Submit those on Twitter with the hashtag AskNASA and tune in to see if it was answered on air. In this one, our user would like to know if the spacewalkers have time for a snack or have any drinks within their suits. While there is no food available for the astronaut in their spacesuit, they do prefer to eat before the spacewalk. However, there is the option for the astronauts to drink inside their suits. There's a plastic water-filled pouch attached to the inside of the hard upper torso, or the largest part of the upper part of the spacesuit. There's a plastic tube with a valve that sticks out of the bag, and that can be adjusted to sit near the astronaut's mouth. Biting that valve opens the tube so the spacewalker can take a drink, and releasing the bite closes the valve once again.
Okay, I've got my green hook.
Copy, Chris.
Heading back.
Roger.
I'm passing up the airlock. You need to do anything here, Chris?
I don't think so. I'm just going to open the thermal cover, put this one in, and grab the reel.
The reel bag?
Yeah.
We copy, Bob. Go to translate for CP13.
Copy. To see the spur.
Roger.
A rare view of the outside of the cupola module in this shot. You can see it up near the top of your screen with the numbers 1 and 2 on those windows. The cupola is essentially the bay window of the space station. We often get pictures from the astronauts taking photos of the Earth from the cupola, but we don't always get a view from the outside.
Okay, on to node 1.
Copy, Chris.
Okay, I'm on S0.
Copy.
and thermal cover coming open.
Copy, Chris.
And Josh, where was the green hook suggested location?
And Bob, we actually had you not dropping the green hook during this, but if you need to, just let us know where you want.
Okay. Okay, I've arrived at the CP13 cable bundle.
Copy, Bob. It should be on about handrail 0269, and that's the wire tie we'll be looking to release one twist from.
Copy. Let me go ahead and drop my green hook down here just so that it doesn't keep windshield wipering across the...
We copy.
Okay, so the green hook,
Large ORU bag and Kurlock bag are in the airlock, and I have P3 reel.
Copy, Chris. We'll need a safer handle check once you're down and out of the airlock again.
It's complete, both are down.
Copy, Chris. We can close the thermal cover and head out to your next work site, the Rat's Nest.
okay, my green hook is on 0270 alpha.
Copy, Bob. Green on 0270 alpha.
Thermal cover closed. Heading out.
Copy, Chris. Copy, Chris. And Bob, just to be sure, the cable you pick up to route should be labeled as Whiskey 4300.
Copy. Whiskey 4300, and there's also a wire tie that's labeled 13.
Copy, Bob. And so, Bob, as you know, we're just going to route that cable starboard across the top of the lab. Your choice on the handrail locations, but let us know where you drop the wire ties.
Copy.
And Bob, as you are getting closer to the CP13 camera, two cautions. As a reminder, do not use the WC antennas as a handhold and avoid inadvertent contact with that camera and light.
Copy.
Okay. And the rat's nest at the spider cable.
Affirmative, Chris. So I believe you're looking for the same bundle as you had last time. It'll be the starboard bundle. We're trying to identify W4300 as the one that we're going to take and mate to your cable.
4300 on the J4 connector.
And Josh, it looks like this cable doesn't reach.
Copy, Bob. We're looking.
Makes it to handrail 272.
Okay, we copy you're at 272. We'll have a look here. We're probably going to end up wanting to go back and make sure that there's no unnecessary fair leads in taking that cable up. Bob, we were going to suggest that you kind of just temp secure that cable right where you are on the handrail that you have, and then we're going to work back up the lab, up the port side to see if we can find any slack to push forward.
Copy.
Gosh, I have Whiskey 4300 J4. Cap removed. Cap removes on the real P4. There's no FOD. The pins are straight. EMI bands are good.
Copy, Chris. That sounds good. Your go to mate J4 W4300 to P4 W4293.
It's mated. And I'll start making my way out of here.
And just double checking, W4300 is the cable that I've got.
And we've double checked, Bob. That's the correct cable.
Okay. Working my way back.
And Chris, we'll probably focus on finding room in Bob's cable at this point, but for you, you're basically following the same route you followed out on EVA2, and we're not picky on which handrails you use. We just ask that you report them.
Okay. I think I'm self-sufficient. I'll chime in if I need anything.
Copy.
Looks like the SPDM is right here.
Copy.
Are you expecting this cable to go underneath a trunnion pin cover? The cable isn't continuously labeled, so I'm trying to make sure that I can visually still back of it.
We think it should be right there by the trunnion pin.
Copy. Bob, stand by.
This view from Bob Behnken's helmet camera as he works to route the CP13 Ethernet cable.
To the trunnion.
It's adjacent to the trunnion and continues around the circumference. Is that?
That's the correct routing.
Just how can you guys give me a big picture of where this cable routes?
And we can, Bob. We're just trying to make sure we get you the exact right words.
Okay, I'll stand by.
But we need to verify that.
Okay, so Bob, we think we're looking at the correct cable plan here, and basically from the rat's nest, that cable should run port across the top of the lab, nadir, and then once it's sort of a quarter way around the lab is where it takes off towards station forward. That's the big picture. In terms of looking for ideas of slack, we'll take a confirmation from you, but we think there might be a bundle of this wire on handrail 240. That's sort of port side of the lab just before you get to the end cone, 24 or 260. And our thought was that if there is a bundle, we might be able to do that, undo that, and secure some more length that way.
Okay.
And Bob, additional to that, so reference the trunnion pin that we were looking at earlier. There's a handrail near the trunnion pin. I think it's just aft of it. It's handrail 226, and we're curious to know if there's slack bundled there as well.
At 226, I don't believe there is any slack. I'll make my way all the way over there, but from this angle, it doesn't look like any.
Okay, copy. We'll take a look anyway, and then, like I said, that's our first idea. If there's no slack there, then I think unfortunately we're gonna be stuck with continuing to trace the cable station aft, and that's where we'll go have a look at that second handrail 240 and see if we can find any slack there.
I found like a coil. Maybe there was a coil here at handrail 226, single coil.
So if we can confirm that that coil is in cable 4300, then we should be able to undo that, I believe. Yeah, the key, and I understand, is the difficult part is to make sure we're on 4300.
Yeah, and I think that cable at this point appears to go into a Y. It's another cable. It is labeled 4300. Got a visual on the label, and then that joins a bundle, a larger cable.
And copy, Bob, that's helpful. So that is the correct wire. We understand it runs into the Y and then the bundle. And words here, we want to push any slack we can get out of that forward towards CP13.
It's not really a move the slack forward, but the cable itself is a 3/4 inch diameter cable that goes off in both directions. So I'll start working that little bit of slack that is available back towards CP13.
Copy.
Josh, I'm on the cable highway. No deviations from the previous laydown. Each wire tie has been the same.
Copy, Chris. That makes it simple. Your end stow point is 3222.
Long ways from here, though.
Roger that.
Just for your essay, I'm at the point past the cedar spur where the cable makes the dog leg forward.
Copy.
We're at the 4-hour, 38-minute mark in today's spacewalk. Both astronauts working to route Ethernet cables. You've got a view here from NASA astronaut Chris Cassidy's helmet camera. These Ethernet cables will relay data from payloads on the International Space Station to their various customers.
And Bob, appreciate you tracing that cable back. We're still taking a deep dive on where we might be able to find some extra slack in this system, but nothing for you right now.
Okay. Yeah, I'm going to go ahead and I've got the couple of additional coils of slack out of the cable at this point. I will, or slack added to the end. I'm going to go ahead and secure this wire tie just so that the cable, in case it's long enough, is secured. It's going to be an extensive job to go undo that other cable and try to reposition that Y.
Okay, we copy.
And I don't think there's much I can do with that.
We copy and concur.
Asking for an extension cord.
Yeah.
Okay, how do you guys feel about shortcutting the cable instead of going around the circumference from this point going diagonal a little bit on the end cone?
And that's, hey, actually we're go on that plan.
Okay. I don't know if that'll give us a little bit.
Yeah, it'll give us some. That question had been asked. We were waiting on an answer, but it sounds like we're go for that. So let's see if that gets the extra foot or two.
Teams here on the ground working with Bob Behnken, this view from his camera outside the International Space Station. He is routing the CP13 Ethernet cable, and they're working to ensure he can get the full length of that cable necessary. We also have another Ask NASA question from social media. This one from Victoria, who asks what type of preparation the astronauts do before suiting up and getting ready to head out. Do they eat anything for sustained energy? The astronauts do prefer to eat before they head out of the door, considering it can be 8 or more hours before they are able to replenish themselves once they get back into the airlock.
Just one additional thought here is that we think we only need to get to the base of the stanchion itself because on the camera, the pigtail boom is what we're going to mate to the cable, and that has some length in it, roughly equivalent to the stanchion. So if we can just make the base of the stanchion, we think we might be able to make the connection.
Okay, copy.
However, another task that the astronauts complete before they suit up includes pre-breathing. That consists of 2 phases, and in the first, the crew breathes 100% oxygen through a mask to begin purging the nitrogen from their bodies. In the second phase is when the crew actually gets into their spacesuits and conducts that in-suit light exercise, or IL. They move their arms and legs and raise their metabolic rate just slightly, but it helps speed up and get rid of the excess nitrogen.
Bob, from what we're seeing in your WVS, it looks like that's going to work.
Copy.
I think we are going to want to end up going back and just securing the wire ties along the forward end cone of the lab to kind of tuck the cable down and flush against it, but we have lots of time.
Copy. Okay, I've got it wire tied to the racetrack, and there's about, it's the connector does make it to the base of the stanchion. That's as far as it'll reach. We'll go back and tidy up the cable.
Filter now. Do you want to do the filter now?
And Bob, we're happy with the cable, so we're ready for you to tighten up the wire ties and that on the forward edge cone. We also wanted to offer it up to you while you're out here if you want to go straight ahead and take that cover off now from the camera. We're good with that, whatever's easiest.
Okay, I'll go ahead and go for the cover at this point.
Copy. And so, Bob, with you moving on to the lens filter removal, a couple reminders: avoid contact with the light and the camera, minimize all loads into the PTU joint, and avoid imparting kick loads above the launch restraint bolts.
Okay, copy.
And you just saw the completion of Bob Behnken's routing that CP13 Ethernet cable. He's now moving on to remove a lens filter from a camera. Meanwhile, Chris Cassidy is also working on routing an Ethernet cable, the CP3 cable to be specific. This view is from his helmet camera, continuing to work as the International Space Station flies 262 statute miles over the Caspian Sea.
Just a reminder, Bob, to have your trash bag ready. It'll be non-captive when you get it off.
I've got my trash bag ready.
Copy, and we're 20 seconds from the handover.
Copy.
This view from Bob Behnken's helmet camera as he prepares to remove that lens filter from this camera outside the International Space Station. We've got a quick handover, but we are approaching the 4-hour and 50-minute mark into today's spacewalk, which began at 6:12 a.m. Central Time, 7:12 a.m. Eastern. The astronauts have accomplished all of their scheduled tasks to this point, including the installation of the RITS, or robotics tool storage.
Copy, Bob. Good words. Last thing will be to verify the lens hood is square with the camera.
And confirmation from Bob Behnken that the lens filter has been removed.
Yeah, we're still looking to pick it up on the other side of the handover. So not WVS, but if it looks square to you, we're good with it.
Okay. It looks square. Yeah, it did not move.
Copy, Bob. In that case, with respect to 4300, what we're looking to do, as discussed, is just tighten it up in the wire ties that are existing, and then, if you can, take some closeout photos for us so we're 100% certain of the new routing, and that should complete the task.
Okay.
Bob Behnken is going to make his way back to that cable he routed earlier. He'll be taking some photos so the teams on the ground can verify the new route of that cable while also installing some wire ties along the way.
No little happy world.
We copy, and with that a good time, Chris, for the reminders, avoid contact with the TARS beam near CP3 and verify the cable is clear of the TARS rotational envelope.
See that, it's going to lay right on top. It is laying right on top of the previous laid cable, and confirm it as all clear.
Copy.
So far.
Josh, I will put in one wire tie on handrail 0272.
Copy, Bob.
And the cable itself is going to go inboard of the two antennas. If you continue the cable routing, I think I can't put it over the top of those.
And Bob, we copy. Still no WVS here, but we're good with that routing.
Okay. Go ahead and take the green light, and yeah, I got a green light.
Josh, what's my ending handrail? 2, right? 32222.
And Chris, affirm 322222. And for Bob, that the issue's on us with KU. It's not you.
Copy.
And Chris, on that handrail 3222, we want to use 2 wire ties to secure the bundle.
Yeah, 2 wire ties. And that is where I am right now, 3222.
Copy.
As you can see, we do not have video communication with the International Space Station currently, as we are in a satellite handover. However, we do have audio communication, and teams here on the ground, specifically Ground IV Josh Kutrick, a Canadian Space Agency astronaut there in the center of your screen, is communicating with Chris Cassidy, astronaut outside the International Space Station on today's spacewalk. Cassidy has been working to route a CP3 Ethernet cable along the outside of the station. He's now approaching the end of that task, working to stow the bundle, the cable bundle, to a specific handrail outside the station. With sunset approaching, you can see NASA astronaut Bob Behnken. You can tell it's him with those red rings around the legs of his spacesuit. That designates him as Spacewalker 1, with the backdrop of our mega solar arrays. Both he and fellow spacewalker today, Chris Cassidy, are on their 10th spacewalk.
Yeah, I'm pointing the GoPro along the length of the cable. On the port side, there is a strut or a cable tray of some sort that comes across. The cable goes underneath that into the original handrail. It was tethered to, and then that original tether where it was holding the bundle is still captive of the cable. And I basically had this shortcut underneath the following two handrails, straight up and over that handrail that I gave you the number of that I installed the wire tie on. Basically, I ended up skipping two of the circumferential handrails to get to that location.
And Bob, we copy. We do have your WVS back yet. We think that's a good. We're checking on the fact that, like you said, you skipped two of the circumferential handrails. We'll get right back to you on that.
The cable is as secure as the other cables that are out here.
Copy.
For what it's worth.
Okay, 3222. 2 wire ties in the roll-up bundle. It is at no risk of interfering with the charge rotational envelope.
Copy, Chris. It looks good. We're still waiting on one go back with Bob, so it might be a good time for the final club and half check.
Half dry. Clubs look good. They survived the wire tie raid.
Ooh.
Copy, Chris.
I can just go for a wire tie and try to secure, add one more wire tie to the radial handrail 280. That will help the cause.
And Bob, not needed. We're getting word that we're happy with the routing. We weren't overly concerned with how the cable was tied down. There was a question here about how it ran across the forward micro MMOD shield, but we're content with it now and happy to head back in.
Copy.
And so that, with that, guys, a couple cleanup items. Bob, we check you heading back in, and Chris, just before you make your way in, we're ready for the inventory of that reel bag whenever you are.
Oh boy, okay.
Do you need a glove and hat from me, Josh, or you can do that? Don't stop right now before I pick up my green hook and head back.
And Bob, hey, firm, we'll take it now.
My hat is dry. RTV on my left hand looks about the same, just a flap on the index finger, and there is a little bit more off of the palm, kind of in the right below the base of the index finger. And my right glove still looks to be pristine.
Okay.
To my green hook and then start making my way back.
Copy, Bob, and we concur. Green hook up and back to the airlock. For Bob and Chris, we just passed the 5-hour mark. 5 hours. We're still good out to a 7-hour PET, but obviously we're on the way back in.
Copy.
Teams here on the ground confirming they are satisfied with the work Bob Behnken has conducted routing that Ethernet cable.
Josh, you ready?
We're ready.
Okay. You have the reel bag itself. On the outside, there is a wire tie caddy with 9 wire ties in it. There are 2 adjustables going from the wire tie caddy attached to the bag. There is a long duration tie down tether. And there is an adjustable, a cap and a plug. And the
Copy, Chris. That's a good config on the bag.
Plug remains on the end of the cable we just paid out.
Yeah, we concur. Good bag.
Okay.
Think they are?
And you just heard NASA astronaut Chris Cassidy, the commander of the International Space Station, reporting out on the inventory of his reel bag.
Sure, we have all the camera gear with us, so 2 GoPros and a still camera between the 2 of you.
That's affirmative. I've got a still camera and a GoPro.
And I have a GoPro, a mutt, and adjustable.
Sounds good.
I guess there's a red on there too. Yeah, red on there too.
Copy.
retrieved my green hook.
Copy, Bob.
Just for
As you can see from Commander Chris Cassidy's helmet camera, he is now on his way back in toward the airlock. We're at 5 hours and 8 minutes into today's spacewalk. Let's take a look back at everything the astronauts have accomplished. Today was scheduled to be a battery replacement spacewalk. However, the first 3 of this series of 4, the astronauts worked so swiftly that they completed those battery removal and replacements in the last spacewalk. There's still one more battery that needs to be installed. It's already on the International Space Station following a lithium-ion battery tripping last year. It will be installed in a future spacewalk. But today, the astronauts made it on internal battery power at 6:12 a.m. Central Time, 7:12 a.m. Eastern Time. Their first task was to install the RITS, or the Robotics Tool Storage, a protective storage unit outside the space station. It's permanently installed now to the Mobile Base System, or MBS. Inside the RITS are 2 RELs. That stands for Robotics External Leak Locators. Those are attached to the inside of the RITS, and the RELs can be picked up by the Special Purpose Dexterous Manipulator. That's Dexter. It's essentially the hand of the Canadarm2, and those RELs can be used to detect ammonia leaks on the outside of the space station. Following installation of the RITS and the necessary cables needing to be routed, the astronauts moved on to remove some H fixtures.
Closed and locked. On the airlock D-ring extender with my anchor hook and my right waist tether, my right D-ring extender has the crew lock side closed and locked. Agree, I'm gonna unhook my tether.
Chris, we copy you closed and locked to the airlock D-ring extender, and you have a go to release your anchor.
Copy. Hey, Bob, I see you there.
The astronauts' second task they accomplished today was the removal of the 1AH fixture.
Put this scoop in there.
This was first attempted on July 1st and was met with some trouble, but with the proper tools today, the astronauts were able to release those H fixtures for future power system upgrades.
The other side has it. Okay.
I see the gates closed.
As Chris Cassidy removed that 1AH fixture, Bob Behnken worked to clean up the integrated electronics assembly from the previous 3 spacewalks. He then moved to the 3BH fixture and removed that smoothly as well.
Roger.
Both astronauts then made their way back to the airlock for a safety tether reset, preparing them for the next task. That task was preparation of Node 3's end cone, also known as Tranquility, for the attachment of the NanoRacks airlock later this year. The NanoRacks airlock will arrive on a SpaceX rocket later this fall, and it will be the first commercial airlock on the space station.
Colonel Behnken.
You can see the astronauts now heading into the airlock once again, but now because all of their tasks are complete.
Right. I'm in. Copy.
Transition to the airlock D-ring extender.
Following the preparation of the Node 3 end cone, which included tying back 3 axial shields, both astronauts went on to route Ethernet cables. Chris Cassidy focused on the CP3 Ethernet cable, while Behnken worked on routing the CP13 cable. He then also removed a lens filter from the CP13 area.
My left waist tether is closed and locked to the airlock D-ring extender.
Copy that, Bob. With that, you can pick up your anchor, stow it on your mini workstation.
Complete.
And Bob, can we just And Bob, we just want to verify the small hook of your waist tether is to your D-ring extender locked.
It is closed and locked. My D-ring extender.
Copy that. We'll pick the anchor up, ingress, and a reminder to have one final look at that pit pin as you go by it, please.
Okay. Okay, I don't see the pit pin. Yeah, it's not installed. Like it's floated over here to the back.
And Bob, we copy, and we're looking in your WVS.
I've reinstalled the pit pin.
Copy, Bob. Thanks.
I floated all the way over behind this white little in the hole that's on that support.
Roger.
Anything else, Josh?
I'm just looking around the room one last time, stand by. And Bob, if you don't mind, since we do have lots of time, we're at 5:15. we would like you to take that pip pin out again, actuate the detent mechanism, and just see if you can see whether or not the ball detents are working and moving.
Okay.
Workstation clean. You want me to take anything?
I think I'm pretty good. I could turn off the GoPro, but I think that would be probably not worth the effort.
Okay.
Okay, so I'm able to actuate the pip pin when it is not installed. I'm kind of, what you can't do is I can pull it back out. You can see that on my WVS.
Yeah, we can see it.
I can pull it out. Then when I push it in, it stays in. Might be a way to push it in and then try to hold on to the collar when I reinsert it.
We're happy for you to give that a try.
Okay, so if I insert the pip pin and hold on to the collar, I can secure it, I can get it to get stuck in there. I can pull out the spring mechanism. I don't know how long it will stay like that because it just needs to get bumped and then it will compress again. But it's a captive if it gets snagged right now. But if you push it in, it will stay that way. Could cycle it several times just to see if we can get it to pop back out. I don't know if that's of value to you or not.
Okay, thanks, Bob. That's very valuable. Yeah, very good info. We can see it in your WVS, and I think we're pretty much finished up with it. So we'll leave it inserted as best you can, and that'll be it.
With Chris Cassidy now inside the airlock, this is a view from the helmet camera of Bob Behnken. He's troubleshooting a pip pin. That stands for push and pull.
And so, Bob, unable to see, but you are going to close the thermal cover and attach the Velcro strap.
And Bob Behnken is now also heading back inside the airlock with a go to close that thermal cover.
The large RU bag is large now, isn't it?
Yeah.
And this view inside the International Space Station.
And Bob, I think you're looking at the same thing as us. Similar to last time, if you can, hold the handrail and try to pop it back out to get rid of that gap in the thermal cover.
A view back inside from Bob Behnken's helmet camera, you can see that thermal cover of the hatch is closed.
Gosh, I've cycled it several times. It's about the extent of it. Keep trying.
The goal is a 5 inch.
Okay, copy, Bob. Thanks. It sounds like the limit is 5 inches, but that looks to be, it's certainly less than it was. So.
Yeah, it looks all about the same to me. It's probably about 3 inches or less on the forward side, and maybe 4 on the aft.
Copy. Yeah, we're going to continue inbound. So, Bob and Chris, onto the SCU steps. You can remove your SCUs from the storage pouches, remove your DCM covers, Velcro to the DCM, and connect your SCUs. Let me know when that's done.
Yeah, that's in work.
Copy in work.
Just trying to keep your feet from down into the thermal cover there.
Oh, okay.
My SCU is locked.
U2 SCU locked.
Copy, locked on both.
And this view from the equipment lock portion of the Quest airlock.
To off, forward, and expect a water off message.
Water is off.
Water off.
Copy. We're starting the timer.
That's NASA astronaut Doug Hurley awaiting his crewmates. They're currently in the crew lock portion of the Quest airlock.
Good.
Still waiting on the opportunity to close the hatch. However, the spacewalk does not end until repressurization begins.
A lot of bags in here. Luckily, the Ritz and Team Dave made it happen, so.
Amen.
Hey, congratulations again to the H-Fixture team that's coming up with a plan with OSO's help to get those 2 fixtures removed.
Thanks, Bob. And Bob, that's the 2 minutes. So for Bob, verify outer hatch clear of hardware.
Okay, the outer hatch is clear of hardware.
Bob, verify handle position per hatch decal.
Okay, the handle position is per the hatch decal.
Bob, close and lock the hatch.
Copy.
Also now in view inside the equipment lock portion of the Quest airlock, Roscosmos cosmonaut Anatoly Ivanishin. And the astronauts are closing the hatch.
The hatch is closed and locked.
Copy, Bob. So into the pre-repress steps for EV1 and 2, we want to check SCU connected to DCM.
Verified for EV1. Verified EV2.
Copy. EV1 and 2, check water switches off.
EV1, water switches off.
EV2, water off.
EV1, check EV hatch closed and locked.
The EV hatch is closed and locked.
EV2, on the UIA, check oxygen for EMU 1 and 2 valves, both of them open.
Oxygen, EMU 1, EMU 2, both valves open.
EV2, on the UIA, you can switch power for EV1 and 2, both to on, and check that the power EMU 1 and 2 lights are on.
EV1, EV2, power is on, 2 EMU LEDs.
Copy. EV2, check the EV1 and 2 voltages.
EV1 and EV2 voltage are both 18.6.
I copy 18.6 on both. EV1 and 2 on your DCM, switch power to SCU, expect a warning tone.
EV1 coming to SCU.
EV2 SCU.
Copy SCU on both. So Chris and Bob, a pleasure working with you today. Thanks for the help, and I will turn you over to Doug. Good luck on the rest of your mission.
Thank you, Josh.
Thanks, Jeff.
Appreciate
Good job.
Yep.
Okay, welcome back. On your DCMs, take your O2 actuator to press.
Work.
And work.
EV1, O2 actuator is in press.
EV2 O2 actuator in press.
Copy, both in press. Bob, check the EV hatch MPEV is closed.
Copy. The EV hatch MPEV is closed.
Okay, next I'm going to start throttling the IV hatch equalization valve. Just let me know if it's too much, and I'll throttle it slowly to norm. How copy?
EV1 copy.
EV2 copy.
We are now approaching the 5.5-hour mark into today's spacewalk. Yes, even though the hatch is closed and the astronauts are back inside the crew lock portion of the Quest airlock, the timer still continues, as it will not stop until repressurization of that portion begins.
Okay, it's in norm. When we get to 4.0, expect an alert tone.
Copy.
Copy.
Good rate for EV1.
Good rate, EV2.
See good rate. stopped at 5.0 and we're timing for 2 minutes for stabilization.
Copy.
And with the beginning of repressurization of the Quest airlock, we have the end of today's spacewalk. That rounds out at 5 hours and 29 minutes from the time the astronauts switched their suits to battery power at 6:12 a.m. Central Time this morning, 7:12 Eastern, and ending at 11:41 a.m. Central Time, 12:41 p.m. Eastern, with the beginning of repressurization.
Got a lot of little funnies with that, huh? With display and then bucket debris and a cable that was too short.
Yeah.
But the H-fixers came through, so that's good. Does the last one feel like the first one? Or the 10th one feel like the first one? I don't want to presuppose anything.
No, I'm a little more comfortable on the 10th one than the first one. View's always amazing, though.
Yeah.
Okay, there's 2 minutes and it was stable. We'll wait 1 more minute.
Sounds good, guys.
Cassidy and Behnken discussing their experiences today. Both of them have just completed their 10th spacewalk.
Okay, there's another minute and pressure's still stable. Go ahead and check your glove heaters are off.
V1 glove heaters are off and no contamination.
AV2 glove heaters off and no contamination.
Okay, copy both. On your DCMs, take your O2 actuator to IV.
Didn't work. EV1 O2 actuator is IV.
AV2 O2 actuator IV.
Copy both in IV. We're going to open up the equalization valve again. Just let me know how it feels as we get all the way back to normal.
Copy.
Okay, equalization valve's in normal.
Copy.
Good rate for EV1.
Good rate EV2.
EV2 good rates. Expect a alert tone when we get close to DPDP is 0.
Copy.
Air molecules hustle back in here a lot faster than they hustle out of here.
Because science.
Because science, yep. I have that feeling where the divers are swimming me through the wall right now.
Yeah.
Just totally relaxed.
Except that I don't feel like I've mortgaged the future as much as I typically would on a NBL run.
Thank you.
The RTV peel off on your left-handed yet, or did they say it'll stay good?
No, they are rock solid, both of them.
And with the conclusion of today's spacewalk at 5 hours and 29 minutes, let's take a look at some spacewalk statistics. This was the 231st spacewalk in support of space station assembly and maintenance, the 7th this year. This makes the 4th spacewalk for the Expedition 63 crew. It's the 10th spacewalk for Bob Behnken, and his total time spacewalking is 61 hours and 10 minutes. It's also the 10th spacewalk for Chris Cassidy, his total reaching 54 hours and 51 minutes. Today's spacewalk lasted 5 hours and 29 minutes, and of all spacewalking time across those 231 in support of station assembly and maintenance, that equals 60 days, 12 hours, and 3 minutes of spacewalking time. Also notable for Chris Cassidy, he is now 9th on the all-time list of spacewalking time, while Behnken is now 4th on the all-time list for spacewalk time. They both, now with 10 spacewalks, tie Michael Lopez Alegria and Peggy Whitson as the only other U.S. astronauts to conduct 10 spacewalks in their career.
Be pretty close.
Depressurization continues in the Quest airlock, and this look inside the International Space Station Flight Control Room.
Here. Airlock, we're going to go to post-EVA, step 1.
That's Flight Director Allison Bollinger in the black jacket. She led the teams throughout the spacewalk today. NASA astronaut Doug Hurley opening that hatch between the crew and equipment lock portion of the Quest airlock.
Okay, copy that. Houston, if you can take care of step 4.
Step 4 is in work. And airlock step 4 is complete, so at this time the EV crew is no longer hot mic to the ground. We do still have your data, and you're go to continue.
That's the voice of NASA astronaut Anne McClain, now serving as the Capcom for the crew now that they are back inside the International Space Station. And as they bring Cassidy and Behnken back and help them doff their suits, another look at the accomplishments of today's spacewalk. The spacewalk began when our astronauts switched their suits to internal battery power at 6:12 a.m. Central Time, 7:12 a.m. Eastern. The first task was the installation of the robotics tool storage, also known as RITS, a storage unit outside the station that will provide thermal and physical protection for tools. After installing RITS and routing some associated cables, Cassidy moved on to remove the 1A H fixture. The H fixtures were used for ground processing solar arrays prior to launch, but needed to be removed for future power upgrades. The first attempt to remove these was on the July 1st spacewalk. With no luck on that day, the astronauts returned today and were able to more easily release those fixtures. As Cassidy removed the 1AH fixture, Bob Behnken worked to clean the integrated electronics assembly area after the last 3 spacewalks in that location. He then moved on to remove the 3BH fixture, another one of those necessary for removal for future power system upgrades. Once those tasks were complete, the astronauts headed back to the airlock for a safety tether reset. This prepared them for their next task, NanoRacks airlock preparation. The NanoRacks airlock will be the first commercial airlock, and it will launch on a SpaceX rocket later this fall. Our astronauts headed out to the Node 3, or Tranquility, end cone. Here they tied back 3 axial shields, preparing that space for the future airlock to be installed once it arrives later this year. After completing the work at the Node 3 area, both astronauts moved on to some cable routing. Chris Cassidy routed the CP3 Ethernet cable, while Bob Behnken focused on the CP13 cables. And once complete, Behnken moved on to remove a lens filter from a camera in the CP13 area. The spacewalk was originally planned to continue power upgrades through the removal of nickel-hydrogen batteries with their replacements, lithium-ion batteries. However, these 2 astronauts worked swiftly through those procedures in the first 3 spacewalks of this series, therefore leaving the opportunity for today's task to be completed. All in all, that totals out at a 5-hour, 29-minute spacewalk and a big thumbs up from Chris Cassidy. And with Chris Cassidy back in the equipment lock portion of the Quest airlock, we now see Bob Behnken has been brought in as well. Anatoly Ivanishin and Doug Hurley working to remove the SAFER, the Simplified Aid for EVA Rescue, that sort of jetpack backpack we discussed. Fortunately, that was not used today, as it's only intended for a crew member to maneuver independently of the space station in case they were to become detached from a tether. The International Space Station currently flies 269 statute miles over Chile, and a big accomplishment today for these two spacewalkers. Both just completed their 10th spacewalk. This puts them in a tie with Michael Lopez Alegria and Peggy Whitson. They are now the only other U.S. astronauts to conduct 10 spacewalks in their career. Chris Cassidy is also now in 9th place on all-time spacewalking list, and Bob Behnken is 4th on that list. As our astronauts prepare to doff or remove their suits, another look at today's spacewalk statistics. It was the 231st spacewalk of Space Station Assembly and Maintenance, the 7th spacewalk this year, and the 4th of Expedition 63. Of all spacewalks conducted through Expedition 63, they total at 23 hours and 37 minutes. It was Chris Cassidy's 10th spacewalk. He now has a total of 54 hours and 51 minutes of spacewalk time and is 9th on the all-time spacewalking list. Bob Behnken also completed his 10th spacewalk and now has 61 hours 10 minutes of spacewalk time, 4th all-time on that list. They both tie with Michael Lopez Alegria and Peggy Whitson as the only other U.S. astronauts to conduct 10 spacewalks throughout their career. But of these 231 spacewalks at the space station, that time totals up to 60 days, 12 hours, and 3 minutes.
Houston, if you could just give me a thumbs up when you hear me. We were seeing a little bit of a smudge on Chris's WVS camera. So before you take the helmet off, or as you take the helmet off, we're wondering if you could just peek at his center camera on his helmet to see if you happen to see anything like a smudge on it or something attached to the front of that camera.
As they remove the helmets today, the crew on board the space station will take an extra look at the WVS on Chris Cassidy's helmet. That's the wireless video system, or the helmet camera that you saw today. This isn't the only dynamic